So there's our vocabulary for today. We got variables, substitute, and integer. I'm not going to read them for you because I know that you can do that. But take a look at those, and if you're having any trouble remembering them, please look at Canvas and study those flashcards using your non-school email. For today, we're going to evaluate expressions, more vocab. We're going to work it down to a number, and it's not going to have an equal sign for the most part. We're going to replace all unknowns, all variables, with a value to find the results. Function notation is a way to identify the output and the input being used. Boring things like f of x and g of x and h of x are a few ways you'll see the functions, but the letter in front of the variable typically has real-life meaning, and I'll provide you with that real-life meaning with the first couple examples. X, or the number in parentheses, is the integer, the input that is being evaluated, whereas the other number, the other value, is its output. So, how many people are excited about going apple picking? Anybody really big into that? So this function actually represents what we're talking about. And what we're talking about are apples and minutes that we spent picking apples. So A represents how many apples, and X represents the number of minutes spent picking the apples. We're going to do this as an I do, we do, and you do. And so, well, let's keep it basic and know that 4 is the number we're going to use for x, okay? So because they changed x from x to a 4, I substitute in 4 to the expression wherever x was. And I get 3 times 4 plus 5. So just simple substitution. And then we keep this A4. This isn't going to change the entire time, and we'll talk about that in a moment. Order of operations, which we've just covered, says to do multiplication before addition. And then finish this up as A4 equaling 17. And you're probably like, why in the world is it written like that? Do we have to do something about the 4? And no, you don't. This is function notation, and it's telling you the story here. The story is after 4 minutes, they picked 17 apples. So what we do double I and A10. So A10, again, remember x is the number of minutes. So what we're changing is the number of minutes. Instead of 4 minutes, how many apples did we pick after 10 minutes? So asking the audience for this we do, where does the 10 go? All right. Yeah, so if it's 3x plus 5, it's now 3 times 10. Notice how I use parentheses for the number I'm substituting in. Shows multiplication, makes it nice and neat. Order of operations says that I'm going to multiply, then add. I can do this all at once because, we're educated people here. 3 times 10 is 30. 30 plus 5 is 35. But more importantly, what in the world does A10 equal 35 mean if we're talking about Mr. Petrie and his family going apple picking? All right. After 10 minutes, there's now 35 apples in the bag. Right, so if you're looking at this at home, please complete that question, bring it in, and we can talk about it the next time I see you in class. I know that this might be getting a little ahead of ourselves, but Halloween's the next big holiday, right? So how many people are going to be trick-or-treating this year? One more typo in here that I have to apologize for. Let X be the number of houses. Houses, okay? So this year might be your last year to go trick-or-treating. You go out and plan your route. You come up with this function to determine how many pieces of candy you receive, because obviously you want to try to get as much as you possibly can. So you come up with CX equaling 2X plus 10. So what in the world does that mean? Well, it means that C represents the pieces of candy. So C for candy. Obviously that makes good sense. X for houses, because we typically use X as our input. And let's say that this equation, all right, this expression, you came up with by starting with 10 pieces of candy and averaging 2 pieces per house because they're cheap and they don't give you the real big ones, right? We all know the houses with the full-size candy bars. You go to those ones first, right? Right. So, how could we possibly have said we have 10 pieces of candy to start? So if you're not quite sure what we're doing here, 30 is the input. That's what we're going to substitute into the expression wherever we see x. So 2 times 30 using parentheses to show multiplication, and then adding 10. Keeping C30, again, I can't stress enough that this is not multiplication, it's just the function notation that we have to get used to seeing. I'll keep it together here. 2 times 30 is 60. 60 times 30 is 70. But what does this really mean? Rhetorical question. This is the I do. This means after 30 houses, you have 70 pieces of delicious candy. And you'll be happy to hear that. What do we do? So C45, just help me out here. How many houses have you visited? If it says C45, Troy. 45. Very nice. So what are we going to do with that 45? What are we going to do with it? What's that fancy word? We're going to substitute it in. And what's this going to help us find? The number of pieces of candy. Order of operations, multiply, then add. Hopefully we can do this in our head. 2 times 45 is 90, plus 10 is 100. And I want you to get used to seeing this. You don't always have to keep writing the C45. Sometimes you'll just kind of see the work go down the right-hand side and just know that that is the same. Okay? Who can come up with a statement? How are we doing so far along our way? And remember, I'm not cold calling people now, but that will happen later in the week. So get comfortable now. Natalie. Exactly. After 45 houses, you have 100 pieces. I know a lot of people are running low on room, and they've told me that that's why they didn't write these statements. But please, the statement is probably more important than the actual work because it's putting this into the real world, into real life. All right, so hopefully you did that. If you have any questions, please bring it into class and we can talk about it in class or during advisement. Last thing we're going to do is, again, go back to the calculator, and we're going to go with the boring ones. No context, no apple picking, no candy, just plain old substitute, all right? I don't really like these, so let's make up a funny story. What do we want to use for F? No. It's going to start with an F. Friends? All right, cool. So we have got a set of friends, and after so many minutes, this is how many friends were left at the party, all right? So what we know is it's been -4 minutes. We're going to have to go backwards in time somehow. We'll have to find Loki. Anyways, -4 equaling 9 plus. Here's the big part. We got to use parentheses. We made a big deal about parentheses last time. What do we know about -4 to the second power when it's in parentheses? It does become a positive. Good, Troy. Just raise your hand next time for us. And this would be 9 plus 16, which means 4 minutes ago, we had 25 friends. So people are clearly leaving the party because 4 minutes ago, we had some people there. Anyways, the important part is how to use your calculator. Oops, you didn't see that. So let's get that calculator out and remember to type what you see. So for instance, 9, and we don't have to do the whole function notation, just after the equal sign, plus, use parentheses because that's the best way to substitute. Remember the negative button is below the 3, -4, close the parenthesis before you square it. How do you square it? X squared will square it, or up arrow and 2 gives you the exponent of 2, and hopefully we will see 25. Voila. Bam. Yes, Troy. So we're going to take the function and substitute 12 in for x, and that's going to give us -2/3 times 12. Let's substitute with parentheses, plus 6. I know a lot of us don't like fractions. We'd rather not deal with fractions. So let's show you how to do this in your calculators. So the easiest way, if you can remember, is the alpha button and the y equals. That pulls up the fraction creator, and if you just press enter, bam, it makes it look like the exact fraction. Now that negative sign, we got to deal with it. We don't do it twice, we just do it once. So -2, and then put that over 3. You could have put it in the denominator, but why not just do it from the start? Arrow to the right to get out of the bottom. We substituted in 12, and we were adding 6. As long as it looks the same on paper as it does in your calculator, it will do it all at once. And we had -2. So unfortunately, all the gorillas decided to leave, and they ate a couple of people on their way out. So there you go. All right. Hopefully that helped. I got to let you go with my tagline. Thank you very much for watching on the video. We'll see you on the flip side.